Let's take a look at number 2 in section 2.6. So they give you a graph here, and this graph is usually what we expect to see right here when we're talking about the squeeze theorem. We have an upper limiting function right here in blue that they're calling u of x, a lower limiting function here in green that they're calling L of x, and then this middle function in red here, y equals f of x, is really the one that we're interested in. And why I say this is the typical drawing right here, you can see that you've got this one function u of x up here on top. The green function L of x is always on bottom, but maybe not surprisingly, those three functions all converge and come together at this ordered pair right here, which appears to be 3 and then a y value of 1.5. So what's going on here? In figure 7, they want to know is f, which is the middle function, the one we're always concerned about, squeezed by u and L, the other two, oh, and I just realized that stands for upper and lower, at x equals 3. So it's really two questions right here. So at x equals 3, the answer to this one right here would be a yes. And the reason why is because both of the upper and lower limiting functions seem to have the same limit right here at x as x approaches 3. So the reason we would say right here is because the limit as x approaches 3 of one of the functions, u of x, is equal to now the limit as x approaches 3 of the lower limiting function, which I'll call L of x. And because the upper and lower limiting function have the same limit value right there, then, I don't really think you need to write this, but you could then conclude that the limit as x approaches 3 of your that's a 3, sorry, of your middle function, f of x, would have to equal the same value as the others, which would be a 1.5. And I suppose I could have said right here that both of those limits were equal to that value right there. So, in essence, the squeeze theorem works here at x equals 3 because all three functions have the same limiting value of 1.5. However, when we get here now, they asked you for a second question here, as x is approaching 2, the answer to that one is going to be a no. And the reason for that one, if we focus on what's going on right here at 2, all right, guys, it kind of looks like the upper limiting function in blue and the lower limiting function in green are getting pretty close to each other, but it doesn't look like they converge and squeeze at the exact same value. So my explanation for why the answer is no here would be because the limit as x approaches 2 of the upper function, u of x, does not seem to equal the limit as x approaches 2 of the lower limiting function, which we would call L of x. And for that reason, we cannot make any conclusion about the limit as x approaches 2 of f of x right there in the middle. Your book uses the phrase here that the function f of x is squeezed at x equals 3, hence the name squeeze theorem, but they use the phrase trapped at x equals 2. I hadn't heard that before this book came along right here, but anyway. So that middle function is, it says trapped in between them, but not squeezed, so we cannot make a conclusion here about the limit of f of x as x approaches 2.